Hello, 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 family. Welcome to another session of Maths Fanatics 24/7. If you haven't hit the subscription button, please do so and share with family and friends for this powerful content on mathematics from grade 10 to 12. Okay, so ladies and gentlemen, on this question, we are required to prove a Chord theorem. So this is the proof of Chord theorem. They want me to prove that DFK, where's DFK? Let's do this. So it's DFK. So they want me to prove that this angle is the same as angle E. It's the same as angle E. Remember, Chord theorem states that the angle between the tangent and this chord, right? Remember, a chord touches the circle in both, so that point and that one, right? So the angle between the tangent and that chord is this one, is going to be the same as the angle formed by this same chord on the alternate segment. So if you check from this dot, there's a line that moves to there. Do you see it? Then from this other side, there's also a line that moves to there, right? So this part here is the angle subtended by this chord, because the lines from both points of this chord form that angle there. So it must be the same as this one. So they want us to prove using other theorems and other geometrical statements that this statement is indeed true. Okay, so we're going to do that now. So remember, a geometrical proof always happens in 3 steps: construction, RTP, and proof. So we are always going to do construction. So this one, we have to draw a diameter. You always draw a diameter. So obviously there's to pass through the center then, right? Sharp. So that's my diameter there. Then I can call that point there any letter that is not here. So I see there's no A here, so I can call this A. Perfect. So now, because I'm proving this angle, I'm proving that this angle is equal to that one. This line, I'm going to join it to that one. Does make sense? I'm going to join it to that one. You don't join it to the one that, because when I'm here, I have 2 options. I can join it to that one or to that one, but I have to join it to the one that I'm not proving. So I'm proving point E, you see, so I cannot join it with point E. I'm going to join it with D. Okay, so here I was just showing you. Sharp. So these are the 2 constructions we made. We need to mention them under construction. So you write construction. And then after writing construction, you are going to tell us what we did. So we're going to say draw diameter AOF, AOF or FOA, doesn't matter which letter you start with. Then we're gonna say join. We joined what? A and D, so join AD. That's our construction. Then you can underline. And then RTP, you always just have to mention it. Required to prove. You mention what the question wants you to prove. In this case, you are given. Then in most cases, the required to prove is always given. D F K equals to angle E. That's required to prove, which is the second part. The first part is construction. The second part you mentioned the required to prove. The third part now you do the proof. Proof, right? Perfect. So ladies and gentlemen, we can do this now, right? We can all agree that this angle here will be 90. Why? Because angle formed by the diameter is 90. Angle in a semicircle. So I'm going to say angle ADF, right? From A to D to F equals to 90 degrees. Your reason is angle in a semicircle. So angle formed by the diameter, we call it angle in the semicircle. Because remember, the reason we say semicircle is that the diameter covers the circle into two equal parts. Okay, perfect. So now I can argue that this angle here, right, this one will be 90 minus angle A using this triangle here. Do you see it? This one, sharp. So I'm going to say angle DFA, which is this one here. DFA is that one, is equals to 90 degrees minus A. Why? Minus angle A. Why? It's angles in a triangle, right? Angles in a triangle add up to 180. So obviously, if I have 90 here, this angle and that one must also add up to 90, which means this one will be 90 minus angle A. Ne? Let me put a cap there. Awesome. But I know that KFA is also equals to 90 degrees. This one, let me use a different color so that you can see it. This angle here ne, is 90 degrees. Why? Because remember, the radius and a tangent forms a 90-degree angle where they meet. Radius is always perpendicular to tangent. So here your reason will be tan for tangent perpendicular radius. Some people just say tan radius theorem. Perfect. And then if the whole angle is 90 and that angle there is 90 minus A, we can argue that this angle here will be A, so that when I add this and that, I must get the 90, right? Perfect. Therefore, KFD equals to angle A, right? Remember, KFD is basically DFK, is the same thing, right? DFK is the same as KFD. Does not matter where you start, but as long as you are following the same path, right? Direction does not matter, which is equals to angle A, right? Perfect. And then we can now do this, no? But angle A is equals to angle E. How did I know that? Check. Okay. I'll use a different color to explain it. Where does angle A come from? Check the blue lines. This is my angle. It's from this side, it comes from point D. Do you see it? And then from this side, it comes from point F. Do you see it? Awesome. But if I go there, from D again, I go there, I'm forming this part. Do you see it? In the circumference. If I'm moving from F and going along this line, I'm going to form that. You see? So which means DF forms two angles on the circumference, which is angle A and angle E. So they have to be equal. Why? Angles subs same chord. Remember, angles subtended by the same chord, they are equal, right? So you're going to say angles subtended by the same chord. Some people says angles in the same segment. This is also a valid reason. So this reason and that one are the same. Therefore, if we prove that this is A and that is A, we can also conclude that this and that are equal. Therefore, DFK must be equals to angle E. Your reason will be they are both equals to angle A. You see? And then you should be done with this question. You have proven what they want you to prove there, you see? And then this is the Chord theorem. Ladies and gentlemen, we're going to meet again in our other sessions of Maths Fanatics. Have a lovely evening and keep on pushing. All the best. Thank you very much for your time.